Hello everyone, welcome to MemoNeet. I am Sarthak and today we'll be discussing the explanations of the part test 1 chemistry portion. Let's start with the section A, question number 51. It's an AR type question. The assertion says T, P and V are state variables or state functions and the reason says that their values depend on the state of the system and how it is reached. So we know that temperature, pressure and volume are state functions, right? They depend on what is the initial state of the system and what is the final state. It does not depend on how the final state is obtained, right? So it will not depend on the path taken to reach the state, and it will only depend on the state of the system. Such functions are known as state functions or state variables. The functions which depend on the path taken to reach the state are known as path functions, and path functions we know are heat and work done, right? So here we're talking about temperature, pressure and volume, which means that assertion is a correct statement. Not talking about the reason, it says their values depend on the state of the system and how it is reached. So the values do depend on the state of the system, but it does not depend on how it is reached. So which means that the reasoning statement is incorrect and the correct answer will be option 4. Moving on to the next question. The next question says, what is the molality of lithium ions in the water of Bay of Bengal, given that it has a concentration of 1.89 ppm of lithium ions? The atomic mass of lithium is given to be as 7. So, what does ppm mean, first of all? So, ppm stands for parts per million. ppm means parts per million, right? So it means that one part of the solute is present in a million parts of the solvent, right? So it can be either in terms of weight or in terms of volume or in terms of number of moles. So here we're talking about in terms of weight. So we can say that 1.89 grams of lithium will be present in 1 million grams of the solvent, right? So if we have to find out the amount of lithium in 1 kg of the solvent, right? We'll just divide the weight of lithium by 1000. So we'll get the amount of lithium in 1 kg or 1000 gram of solvent as 1.89 multiplied by 10 raised to the power minus 3 grams, right? Now we have to find out the molality of lithium ions. So we know that molality can be found out using this formula. The formula for molality is moles of the solute divided by the mass of solvent in kg. So we have to find out the moles of lithium present in 1 kg of solvent. Now here we have the weight of lithium present in 1 kg of solvent. So we can find out the number of moles of lithium which will be present in 1 kg of the solvent, and the number of moles can be found out by if we divide the weight by its atomic mass, which is given to us as 7. So this gives us the number of moles in 1 kg of solvent, which is also the molality as 2.7 multiplied by 10 raised to the power minus 4 moles. So this gives us our option 4 as the correct answer. Moving on to the next question. Question number 53 says, consider the following set of statements. We have three statements and we have to tell which of the following statements is true and which is false. So statement 1 is tellurium forms NaOH type of hydroxide. So what do you mean by NaOH type of hydroxide? NaOH type of hydroxide, we can see that both metal and hydroxide are present in a 1:1 ratio, which means that Na is present in a +1 oxidation state, right? So it means that the statement is trying to say that tellurium will also show a +1 oxidation state more preferably. And we know that it is true because due to the inert pair effect, tellurium is much more stable in its +1 oxidation state rather than the +3 oxidation state. So statement 1 is true. Statement 1 is a true statement. Moving on to the next statements, it says that Sn2 plus is a reducing agent, sorry, and Sn4 plus is a reducing agent. So we have to talk about Sn2 plus and Sn4 plus. So now one thing that we need to understand first of all is that in tin, the inert pair effect is not as much applicable as it is in the lower elements, which is for example lead. So in tin the Sn4 plus oxidation state will be more stable as compared to the Sn2 plus. So Sn2 plus can be either oxidized or it can be reduced, but Sn4 plus will prefer to stay in the Sn4 plus state rather than being reduced to the Sn2 plus. So we can say that Sn2 plus is a reducing agent, but Sn4 plus will not act as a reducing agent. So which means that statement 2 is true and statement 3 is false, which gives us our correct answer as option 3. Moving on to the next question, it says the major product of the following reaction is. The reaction we are given is we have an alkene and it is being reacted with water in presence of an acid. So we know that the addition of water in acidic medium, it is an example of electrophilic addition. It starts with the attack of an electrophile which is H plus. So it will proceed via the Markovnikov's rule. What happens is the H plus will attack on the carbon atom which has more number of hydrogen atoms so as to form a more stable carbocation. So when the H plus will attack on this hydrogen, so our positive sign will be on the other carbon atom. But in this case, a rearrangement will take place to form a more stable tertiary carbocation. If we can see here, this hydrogen will tend to move on this carbon atom to give us a intermediate like this. So this is a more stable carbocation because it is tertiary. So this will be preferred uh, ahead of the secondary carbocation, and that is why the OH minus will attack on this carbon atom, forming option 1 as the correct product, which is 2-methyl 2-butanol. Moving on to the next question, it is again an assertion reasoning type question. The assertion says different number of electron pairs are present in resonance structures. The reason statement says resonance structures differ in the localization of in the location of electrons around the constituent atoms. So the assertion statement says different number of electron pairs are present in the resonance structures. We know that this is a wrong statement because in resonance structures, the electrons are being delocalized. However, they are being delocalized within the atom, sorry, within the molecule. It keeps on moving on different atoms of the molecule. So the total number of electron pairs which is present in the molecule remains constant, which means that assertion statement will be wrong because the total number of electron pairs remains same across all resonance forms. Talking about the reasoning statement, resonance structures differ in the location of electrons around the constituent atoms. We just discussed that this is a correct statement because the electrons are being delocalized from one atom to the other, right? And they stay within the molecule. So assertion is wrong and reason is correct, making option 4 as a correct answer. Moving on to the next question, we have consider the following equilibrium. 2NO2 in gaseous state, which is brown in color, is converted to N2O4, which is colorless, and the enthalpy of reaction is given to be as minus 57.2 kilojoule, which tells us that the reaction is exothermic. Okay. So we are given 4 different statements and we have to tell which of the following statements is correct. So statement A says at low temperature intensity of the brown color decreases. So we know that we have an exothermic reaction. So at low temperature, what will happen? At low temperature, it says that the intensity of brown color will decrease, which suggests that the reaction will move towards the product. It will move towards the right hand side, which is absolutely correct because in an exothermic reaction, if temperature is lowered, the reaction will move forward. So N2O4 is found more, which means that the brown color will decrease in intensity. So statement A is true, right? If we talk about statement B, it says that the equilibrium constant for a given reaction increases as the temperature increases. We just discussed this that when the temperature is lowered, more product is formed, which means if the temperature is low, when temperature is low, the product is more, the product will increase, and if the product will increase, the equilibrium constant will also increase, right? So statement B is incorrect. In statement C, it says that at low temperature, the brown color intensifies, which is again a which is again incorrect statement. And in statement D, it says on increasing pressure, the reaction shifts in the forward direction. So if we take a look at reactant side, we have 2 moles of the gas, and in product side we have 1 mole of gas. So when the pressure is increased, the reaction will shift towards that direction in which we have lesser number of moles. So the reaction will be shifted forwards because there we have 1 mole of product, whereas in the reactant side we have 2 moles of gases. So statement D will be a correct statement, giving us option 4 as the correct option, which is A and D only. Moving on to the next question. The next question says which of the given statements is correct for BF3. So statement 1 says B boron atom is sp2 hybridized. Statement 2 says there is a p pi back bonding. Statement 3 says observed BF bond length is found to be less than the expected bond length, and option 4 says all of the above. So if we consider the structure of BF3, we can see here that boron is present, BF3 is present in a trigonal planar kind of structure, and the hybridization of boron is sp2. if we take a look at the electronic configuration of boron, we have 1s2, 2s2, 2p, 1, right? And if uh, right, so this will be the electronic configuration of boron, and when boron has to form a bond, this electron will move to the p orbital, forming this type of electronic configuration, and the hybridization will be sp2, and thus we get a trigonal planar sort of structure. So statement 1 is correct. If we consider statement 2, it says that p pi back bonding is possible in the molecule. In fluorine, we have a lone pair present in the p orbital, whereas boron has this empty p orbital, as we can see in the electronic configuration. So boron has this free p orbital, so it remains as an empty orbital here, whereas this fluorine has a lone pair. Each fluorine has a lone pair, right? And they back bond this lone pair into the empty p orbital of the boron one by one. So back bonding is also happening in the molecule, and due to the constant back bonding happening, each of the BF bond has a double bond character, and because of the double bond character, their length is lesser than expected, which means that statement 3 is also correct, and our correct answer is option 4, all of the above. Moving on to the next question. The question says, how many radial nodes does a 3D orbital have? So we know that the formula for number of radial nodes is n minus L minus 1. So for a 3D orbital, n is equal to 3, whereas for a d orbital, the L is equal to 2. So if we find out the number of radial nodes, it will be 3 minus 2 minus 1, which gives us as the number of radial nodes as 0. So our correct answer will be option 1. Moving on to the next question, we have figure below is showing that 1 mole of an ideal gas is fitted with a frictionless piston. If we take a look at this figure, this is the figure that we have, right? The total volume of the gas is Vi, and the pressure of the gas inside is small p. If external pressure P external is which is greater than P is applied, the piston is moved inwards towards the pressure inside, because till the pressure inside becomes equal to P external, right? So what is happening? We have a piston, and the pressure inside the piston is P, whereas we apply an external pressure P external, and which is higher than P. So the gas will compress, whichever system we have, it will compress till the internal pressure and external pressure is equal. So the question asks, what does the shaded area in the above figure represent? So it is we have a PV graph. So we know that in a PV graph, the area below the curve gives us the value of work done. So in a PV graph, the area below the curve is equal to the work done, right? So the correct answer will be option 4, which is work done. Moving on to the next question. The next question says, what is the vapor pressure of a mixture containing 1 mole of component A with a vapor pressure of 21 kilopascal, right? So the vapor pressure of component A is given to be as 21 kilopascal, and 2 moles of component B with a vapor pressure of 18 kilopascals at 363 Kelvin. So, and we have to assume ideal behavior. So what do we have to calculate? We have to find out the vapor pressure of the system, right? So we know from Raoult's law that vapor pressure is given as the sum of the partial vapor pressures of the components, and the partial vapor pressure is given as mole fraction multiplied by the vapor pressure of the pure gas, of the pure solution, right? So this is the formula that we have to follow. So first of all, we'll find out the partial pressure of A in the solution, which is given by the mole fraction multiplied by the total pressure of A. So if we have to find out mole fraction, we have 1 mole of A and 2 moles of B. So mole fraction of A will be 1 divided by the total number of moles, which is 3, and mole fraction of B will be 2 by 3. So this gives us that Pa as 21 multiplied by 1 by 3, which is equal to 7 kilopascals, and the partial vapor pressure of B as 18 multiplied by 2 by 3, which gives us as 12 kilopascals. So if we have to find out the total vapor pressure of the solution, we'll get it as the sum of Pa and Pb, which is equal to 7 plus 12, which is 19 kilopascals, which gives us option 2 as the correct answer. Moving on to the next question. The question says, select the reagent which can convert but2ine to trans-but2ene. Okay, so we have but2ine and we have to convert it to trans-but2ene. So for that we use sodium in the presence of liquid ammonia. The reaction follows a free radical mechanism. So what happens is that we have an alkyne, right? So what happens is we have sodium. So sodium gives an electron which causes this bond to break homolytically, and we have a free radical on which the ammonia attacks, and a trans alkene is formed in the end. Okay, so for forming trans alkene from an alkyne, we use this Birch reduction method, sodium in liquid ammonia. And if we have to form cis alkene, so in that case we'll use Lindlar's catalyst. Okay, moving on to the next question, we have the order of stability of the following carbocations is. Okay, we have three different carbocations given, and we have to find out the order of stability. So one is our one we have benzylic carbocation, one we have primary carbocation, and one we have an allylic carbocation. So we know that for the stability of a carbocation or stability of any charge, it is mandatory that the charge be delocalized, right? If the more the delocalization of the charge, the more is the charge stable, right? So the benzyl and the allyl uh, carbocation will be more stable because of resonance, because the positive charge here is delocalized across the molecule because of resonance. In benzyl we have more resonance, and in allyl we have lesser resonance, and in propyl we have only the hyperconjugation from two hydrogen atoms. So that is why benzyl will be more stable, followed by allyl, followed by propyl, which gives us option 1 as our correct answer. The correct order will be 3 greater than 1 greater than 2. Moving on to the next question. The next question says, if a sparingly soluble salt AB with a molecular weight of 100 has solubility 1 milligram per liter, calculate its solubility product. So we have to find out the solubility product for a sparingly soluble salt AB. So if we write the formula, the reaction, what is happening? So the equilibrium will look like this. We have AB, and it will be separated into, let's just forget the charges for now, right? We don't need them. So we have A in aqueous medium plus B in aqueous medium, right? And AB will be a solid. Okay, so when it is dissolving, it will be broken up like this as A and B, and the solubility of both A and B will be S and S, and that will give us KSP as S square. Now the solubility is given to be 1 milligram per liter, which gives us S as 1 milligram per liter, or 10 raised to the power minus 3 grams per liter. Now we have the molecular weight as 100. So if we have to convert this into number of moles, so how we'll convert gram per liter into moles? We'll just divide the weight by the molecular mass, which is 100, and then we get the number of moles per liter as 10 raised to the power minus 5, and we know moles per liter is a unit of concentration, which is molarity, right? So we can write KSP as S square, and in S, at the place of S, we can write uh, the concentration in molarity terms. So it is 10 raised to the power minus 5 raised to the power 2, which gives us the KSP value as 10 raised to the power minus 10 molar square, which gives the correct answer as option 2. Moving on to the next question, we have, what is the correct order of dipole moments? We are given three different compounds. Okay, the compounds are BF3, NH3, and NF3. So we have to find out the dipole moments of the three compounds. So first of all, it's very simple for BF3, right? For BF3, we know the structure of BF3 is a trigonal planar type of molecule, right? And we can see it is a symmetrical molecule. The dipole moments will be towards fluorine, right? And since it's a symmetrical molecule, all these three dipole moments will cancel each other out, and the final dipole moment, the net dipole moment of the molecule, will be 0. So the dipole moment of BF3 will be the least. Now if you have to compare for NH3 and NF3, so what happens is, whenever we have a lone pair, the dipole moment will be towards the lone pair. So in NH3, the dipole moment of the lone pair is towards in the upward direction, and the NH bond, right? Nitrogen is more electronegative than hydrogen. So each bond will have a dipole moment towards the upward direction, right? So all these dipole moments add up, right? However, in the case of NF3, So fluorine is more electronegative than nitrogen. So the dipole moment of the three nitrogen fluorine bonds will be opposite to the dipole moment of the lone pair. And that is why they cancel each other out. So we can see here the dipole moment of NH3 is 1.47, whereas that for NF3 is 0.23. So the order of dipole moment will be NH3, NF3, and then BF3 with a zero dipole moment. So the correct answer will be option 3. Moving on to the next question. The question says, if an electron has n is equal to 3 and only one radial node, what will be the orbital angular momentum of the electron? So first of all, for calculating the orbital angular momentum, so the orbital angular momentum is given by this formula, which is h divided by 2 pi multiplied by L into, or multiplied by under root of L into L plus 1, right? This is the formula for calculating the orbital angular momentum. So now we can see the options, right? We have h by 2 pi in the options, so we need to find out L for that. And for that we have the information given is we have n, and we are given that it has one radial node. So what is the formula for finding out radial nodes? Radial nodes can be found out using this formula, which is n minus L minus 1, right? So, and the number of radial nodes is given to us as 1. So when we put in this formula, we get the value of L as 1. So when we substitute in this formula, we'll get h divided by 2 pi under the root. The value of L will turn out to be 1. So L, sorry, right? So we'll substitute L by 1. So when we substitute L by 1, we'll get 1 multiplied by 1 plus 1, which gives us root 2h divided by 2 pi, which is in our option 3. So option 3 will be our correct answer. Moving on to the next question, we have an ideal gas is allowed to expand both reversibly and irreversibly in an isolated system. If Ti is the initial temperature and Tf is the final temperature, which of the following statements is correct? So we are given relationships between the final temperatures of the reversible and irreversible reactions. Okay, so first of all, we need to focus on the fact that the details that is given. So it is given that we have an expansion and the system is an isolated one. So why it is important to focus on the isolated part is that when a system is isolated, it means that there is nothing around the system, which means that it will have no other bodies to transfer heat to. In that case, we can say that an isolated system is adiabatic, which means that the change in heat will be zero. There will be no heat transfer. So according to the first law of thermodynamics, we know that Q is equal to delta U plus delta W. So if Q is 0, we'll get that minus of delta U will be equal to the work done, right? So now we have this relation. Now we know that the given process is an expansion process. So in expansion, the work done is always positive. So when the work done is positive, it will mean that the change in internal energy is negative, because they have this relation. So the change in internal energy will be negative. And when the change in internal energy is negative, which means that the change in temperature will be negative, and that will mean that Tf will be less than Ti for both reversible as well as irreversible reactions. So we can conclude by saying that the correct answer of this question will be option 3. Moving on to the next question. The question says, what is the concentration of a urea solution that is isotonic with a 12 gram per liter glucose solution? Okay, so we are given isotonic solutions. For isotonic solutions, the osmotic pressures are equal. So we have pi 1 is equal to pi 2, and the formula is C1RT. For osmotic pressure, the formula is C into RT, where C is the concentration. So we can write down C1RT is equal to C2RT, where we take glucose solution as the solution number 1 and urea solution as solution number 2. So from there we get that the concentrations of the two solutions are same. Now we are given that the density of the glucose solution as 12 gram per liter. Now we need to convert this into molarity in terms of concentration, right? So to convert this in terms of concentration, what we can do is we'll just divide this by the molar mass of glucose, which is 180 grams, right? When we do that, we'll get C1 as 2 by 30 moles per liter. Now we'll just put that into this formula, which is C1 is equal to C2, right? So C1 is equal to C2 will be 2 by 30. And again, for C2, we can write weight divided by the molar mass multiplied by the volume. So the molar mass of urea is 60. So when we divide, okay, so we can write C1 is equal to C2 is equal to 2 by 30. So C2 can be written as the weight upon molar mass of urea. So molar mass of urea is 60. So when we write it as 2 by 30, so we'll get the weight as, if we cancel out this, we'll get this as 4 grams per liter, right? So the uh, concentration of urea will be 4 grams per liter. The correct answer is option 1. Moving on to the next question, we have sp3 hybridization of carbon is found in. So we have diamond, graphite, fullerenes, or both diamond and graphite. Oh, sorry, diamond and fullerenes. So we know that diamond has sp3 hybridization of carbon, right? We have a sp3 network of cage-like network of carbon atoms in diamonds, whereas in graphites we have sheets of carbon and all the carbons are sp2 hybridized there. But in fullerenes also all the carbon atoms are sp2 hybridized while forming a closed ball-like structure. Okay, so graphite and fullerenes have sp2 hybridized carbon, whereas diamond has an sp3 hybrid carbon. So uh, so the correct answer to this question will be option 1, which is diamond. Moving on to the next question, we have statement 1 says the Woods reaction is considered the most effective method for synthesizing methane. And statement 2 says 2,2-dimethylbutane can yield 3 distinct structural isomers of monochlorinated derivatives. So we have two statements and we need to find out which of the following statements is correct or incorrect. So the first statement says that the Woods reaction is considered the most effective method of synthesizing methane. So this is an incorrect statement because the Woods reaction, it is primarily used for the synthesis of organic compounds containing carbon-carbon bonds, and the processes of use of coupling the alkyl halides. So it is not a very effective method for synthesizing methane because it can only form a CC bond and methane has only one carbon atom. So if we consider now statement 2, so statement 2 says that if we do the chlorination of 2,2-dimethylbutane, so what we'll have in that, if we first draw 2,2-dimethylbutane, we'll have a 4 uh, carbon chain and then will be 2 methyl groups, right? And let's complete the hydrogen atoms on them. This will be CH2 and this will be CH3. Okay, so when this is done, so now if we talk about monochlorination, so what happens is monochlorination, the type of hydrogen should be same. So if I take a look at this, so these 3 methyl groups are equivalent to each other, and so are the so are the hydrogen atoms that are bonded to it. So if we replace any of these 9 hydrogen atoms, we'll get the same monochlorinated product. Similar for these 2 hydrogen atoms, so this will be the second and this will be the third different type of hydrogen atom. So we'll get 3 possible monochlorinated isomers. So we can say that statement 1 is incorrect, whereas statement 2 is correct. So the correct answer will be option 1. Moving on to the next question. The question says which out of A, B, C and D are not correctly categorized. So we have been given different species and we have to find out whether they are a nucleophile or an electrophile. So first of all, an electrophile is a species that is electron loving, right? So it wants to gain electrons. So it means that it must have an empty orbital or it must have a positive charge on it. Whereas a nucleophile is someone which is nucleus loving, right? So it means it can donate a pair of electron. So it must have a lone pair or it must have a negative charge on it. So if we take a look, we have HS minus, so it has a negative sign, so it is a nucleophile, that is correct. And we have Cl plus, so it is an electrophile, that is also correct. So seeing next, we have BF3. If we recall the structure of BF3, what we know that in BF3 we have an sp2 system, right? And it is electron deficient. We have an empty orbital here at boron. So which means that BF3 is a nucleophile. So it is not correctly placed, right? BF3 is a nucleophile. BF3 is an electrophile, whereas this amine is an amine is a nucleophile because nitrogen has a lone pair on it. If we take a look at option C, we have NH2 minus, so it will act as a nucleophile, whereas this carbon atom has a plus sign on it, so it will act as an electrophile. Now, if we take a look at this D, so we have R3CX, And in the nucleophile section we have CH2H C2H5O minus. So here is a minus sign, so this will not act as an electrophile. So option D is also not correctly matched. So the correct answer will be option 4, because B and D are not correctly matched. Moving on to the next question. The question says, at 1100 Kelvin, the pressure of CO2 gas is measured to be 2 multiplied by 10 raised to the power 5 Pascal at equilibrium in the reaction. The reaction is given. It is the decomposition of calcium carbonate. And what is the equilibrium constant for this reaction at 1100 Kelvin? So it might seem a very simple question at the beginning, but many students make mistake in it, because if we take a look at reaction, we have CaCO3, which is a solid, and it is decomposing into CaO solid plus CO2 gas. So when we are talking about the Kp, we'll only take into consideration the gaseous parts, right? Only the gaseous molecules, which is only CO2. So the pressure of CO2 will be equal to Kp, right? And we also have the pressure of CO2 gas given. So students might just equate it, and there is the mistake that they do. So what we have to avoid is, we have to keep it in mind when we are calculating the value of Kp. The pressure should always be expressed in terms of bar, right? So here the pressure is given in terms of pascals. So to convert pascals into bar, we have to divide by 10 raised to the power 5. So when we divide it by 10 raised to the power 5, we'll get the value of Kp as 2 bar. So the correct answer will be option 3. Okay, moving on to the next question. The question says, maximum dipole moment value is possible in xy2 if the angle is. Okay, so the formula for dipole moments is given as, for a molecule which has three atoms, right? One central atom X and two atoms Y attached on it, right? We have xy2. So we have to find out the angle between we have to find out the yxy angle, so that the dipole moment is maximum. So if the dipole moment of this is mu1 and dipole moment of this bond is mu2, so the net dipole moment is given by this formula, which is mu net is equal to under the root mu21 plus mu22 plus 2 mu1 mu2 cos theta. So we know that the value of cos theta keeps on decreasing from 0 to 90 degree. So when we reach 90 degree, cos theta is 0. So when this value will be 0, so the value of this will be maximum. Otherwise, cos theta term is less than 1, right? And after 90 degree, when 90 degrees cross, the cos theta value will start decreasing in the negative value, right? So when it is negative, so the dipole moment will also keep on decreasing. So the maximum value of dipole moment will be attained at theta is equal to 90 degree when cos theta is 0. So the correct answer will be option 2. Moving on to the next question, we have, which of the following options is allowed? We are given four different sets of quantum numbers, and we have to tell which of the following options is allowed and which is not allowed. So we have different values of n, l, and m. So first of all, let's write down, for any value of n, the values of l allowed are from 0 to n minus 1. Okay, and for any value of l, the values of m allowed are minus l to plus l. Okay, so in option 1 we have n is equal to 4. So when n is equal to 4, okay, when n is equal to 4, so value of L can be 0 to 3, right? 0 to n minus 1, which is 4 minus 1, so 3. So 0, 1, 2, and 3. These can be the possible values of L. So we can rule out the options 1 and options 3, right? Now if we take a look at option 2, we have n is equal to 4, L is equal to 2, but m is equal to 3. Now we have seen that the value of m ranges from minus L to plus L. So m cannot be greater than L. So we can also rule out option 2. So option 4 is the only correct option. Let's review it. We have n is equal to 4. So for n is equal to 4, L is equal to 0 is a permitted value, whereas m is equal to 0 will also be a permitted value. Moving on to the next question. The next question says, consider the reversible isothermal expansion of an ideal gas in a closed system at two different temperatures, T1 and T2, and we are given that T2 is greater than T1. So T2 is greater than T1. So the correct graphical depiction of the dependence of work done on the final volume V is, right? So we have to find out the relation between work done and the final volume. And here we have the graphs in terms of work and ln of V. So that makes our work easy. We have a reversible isothermal expansion. So we know for reversible isothermal expansion, we have the formula for work done as minus nRT ln V2 by V1. And we are also given mod. So if we take mod, we can ignore the negative sign. So that gives us the mod W as nRT ln V2 minus nRT ln V1, right? So if we take a look at this, so we can see that this is an equation of the type y is equal to mx plus c, right? And we have to find out the dependence of the work on the final volume. The final volume, which is V2. V2 is the final volume for us, right? So we have to find out the dependence of work on this final volume. So we can treat this as a constant. So this will be value of C, whereas the slope will be equal to nRT, which means the slope depends on the temperature, right? And we are given that temperature that T2 is greater than T1. So in case of T2, the slope will be higher, right? So when the slope is higher in case of T2, which means that the correct answer will be option 4 here, right? So this will be the correct answer. Moving on to the next question, we have if the ratio of rates of diffusion of two gases X and Y is 2 is to 3, the ratio of their densities is. Okay, so to start with, we can say that the rate of diffusion is inversely proportional to the density. Okay, for any gas, the rate of diffusion is inversely proportional to its density. Okay, so we have been given the ratio between the rates of diffusion of X and Y. So if I assume the rate of diffusion of X as Rx and that for Y as Ry, so we can write it as 2 by 3. This is given to us, and we know that the rate is inversely proportional to density. So we can also write this as under the root dy divided by dx, right? This will be whole under root is equal to 2 by 3. So if we have to find out the ratio of their densities, so dy by dx will be equal to the square of 2 by 3, which is 4 by 9, and that is and from that we can find out that dx is to dy will be equal to 9 is to 4. This gives us the correct answer as option 3. Okay, moving on to the next question. The question says how many BOB bonds are present in a molecule of borax? And for that, we have the structure of borax here. We can clearly see in this that the number of BOB bonds is 1, 2, 3, 4, and the fifth one is this bridging BOB bond. So we can say that there are total 5 BOB bonds in a molecule of borax. So the correct answer will be option 2. Moving on to the next question, the product of the following reactions are. We have been given two different reactions of two different compounds, and we have to find out the products X, Y, and Z. So if we take a look at the first reaction, we have a bromoalkane, and it is being reacted with alcoholic KOH. Now we know that alcoholic KOH carries out an elimination reaction, right? E2 elimination takes place in a bromoalkane, and what is the reaction taking place? A dehydrohalogenation takes place, right? And when the dehydrohalogenation takes place, uh, according to the Setzeff rule, uh, more coordinated alkene is formed, which means that when this bromo group is leaving, so the hydrogen will be extracted from either one or two, right? So instead of one, the hydrogen will be extracted from two in order to form a more substituted alkene group. Okay, so the X will be molecule X will look like this. This will be the structure of X. Okay. So the correct answer can be either option 3 or option 4. So we can cancel out option 1 and option 2 here, right? Now, if we take a look at the second reaction, we have an alkene, and the alkene is being reacted with O3 and zinc in the presence of water. So this is a reductive ozonolysis. So the trick for ozonolysis is what we have to do. We just break the double bond, and on both sides we attach a double bond O. Okay, so this is how we solve an ozonolysis reaction faster. So we can find out that here formaldehyde is forming, and here we have another aldehyde being formed, which is propanaldehyde, right? So we can say that the correct answer is option 4. Okay, moving on to the next question, we have three different molecules are given, and it is asking which of the given compounds can exhibit tautomerism. Okay, so these are the three different compounds that are given to us in the question. So we have to find out which of the following can give us tautomerism. So what happens in tautomerism is, if we draw the molecule 1, right? So this is the structure of molecule 1. So for tautomerism, one of the major requirements is that we must have a alpha hydrogen, right? So if this is the carbonyl carbon we are talking about, so the carbon next to it is known as the alpha carbon atom. So this must have a hydrogen atom. So what happens is this hydrogen atom, the electron density from this hydrogen atom moves here, and an enol is formed. So this is what happens in a tautomerism reaction. For this we must have an alpha hydrogen atom, or in the case of alpha beta unsaturated ketones, we must have a gamma hydrogen atom. Okay. So if we take a look at these compounds, here we have an alpha carbon, and this has a hydrogen atom as well. In this also the alpha carbon has a hydrogen atom, but in this compound there is no alpha hydrogen and no alpha hydrogen here, but we have an alpha beta unsaturated ketone, and it has a gamma hydrogen atom, right? So all three molecules will show tautomerism. So the correct answer to this question will be option 3, which is 1, 2 and 3 all. Moving on to the next question, we have, for a reversible reaction, A solid plus B gas gives 2C gas at any temperature T. What is the relationship between Kp and Kc? And the relation is given between Kc and Kp as Kc is equal to Kp multiplied by RT raised to the power x. Okay, so we have to find out the relationship between Kp and Kc. So we know that the relation between Kp and Kc is given as Kp is equal to Kc into RT raised to the power delta Ng, where delta Ng is the change in the number of gaseous molecules. So the change in number of gaseous molecules is given by the number of moles of gases in the product side minus the number of moles of gases in the reactant side. So if we do that, if we take a look at the reaction, we have two molecules of gas in the product side, whereas one molecule of gas in the reactant side. So we can write delta Ng as 2 minus 1, which gives us 1, and delta Ng as 1. So if we substitute in this formula, we get Kp is equal to Kc RT raised to the power 1. But in the question we are given Kc is equal to Kp, right? So if we take RT to the other side, we'll get x as minus 1. So the correct answer will be option 3. Moving on to the next question. The question asks, which of the following are isostructural species? So we have four different options and we have to find out the isostructural species in these. So if we take a look at option 3, we have sulfate, phosphate and PF4 minus. So all these three molecules have one thing in common, that they form 4 sigma bonds, right? All of these form 4 sigma bonds, and none of these have a lone pair and no lone pair, right? So this means that the hybridization of all these four atoms will be same. All will have four hybrid orbitals, as we can see here as well. In this calculation we have four hybrid orbitals for each of these three molecules. So when we have four hybrid orbitals, it means that the hybridization is sp3, and when hybridization is sp3, so the structure will be tetrahedral. So all these three molecules will be isostructural. So our correct answer is option 3. Moving on to the next question. The question says, what is the ratio of the energy of the first excited state of a hydrogen atom to the first excited state of a helium plus ion? So we have to be careful in this question, because a mistake a lot of students make is that they get mistaken by this. We are given first excited state, not the first state. So for a first excited state, we have to take n is equal to 2, right? Many students make a mistake and take n is equal to 1 when they see first excited state. So ground state is n is equal to 1, whereas the first excited state is n is equal to 2. So we know that energy is given as minus 13.6 z square by n square. So we can write that energy is directly proportional to z square divided by n square. So we have to find out the ratio of energy of hydrogen divided by energy of helium plus. So for hydrogen, the atomic number, which is z, is 1 for hydrogen, and for helium the atomic number is 2. So we can write 1 divided by 2 multiplied by the value of n is same for both, so that will cancel out. So we get 1 is to 4. So the correct answer will be option 2. Moving on to the next question, we have the bond dissociation energies of X2, Y2 and XY are in the ratio 1 is to 0.5 is to 1. Delta H for the formation of XY is minus 200 kilojoule per mole. The bond dissociation of energy of X2 will be. Okay, so first of all, we assume that the bond energy of X2, XY are for X2 we assume X kilojoule, for Y2 we assume 0.5 kilojoule, 0.5x kilojoule, and for xy we assume x kilojoule. Now we are given the bond, we are given the enthalpy of formation. So for enthalpy of formation, here we have to take care that enthalpy of formation we talk about the formation of 1 mole of product. So we'll have the equation as half x2 plus half y2 gives 1 mole of xy, and the enthalpy of formation is given to us as minus 200 kilojoule per mole, and the enthalpy of formation is equal to the sum of bond energy of the reactants minus sum of bond energy of the products. So here we have the bond energy of x2 we assumed at x, so we have half mole of x, so we'll write half multiplied by x. For y the bond energy was 0.5x, so here we'll write half multiplied by 0.5x, and this will be subtracted by 1 mole of xy we have, which is 1 into x. So this will give us, you write x by 2 plus x by 4 minus x gives is equal to minus 200 kilojoule. So when we solve this, we'll get x as 800 kilojoule per mole, and x is same as the dissociation energy of x2, so the correct answer will be option 1. Moving on to the next question, we have which is correct statement for diborane. So first of all, let us draw the structure of diborane. So if I draw the structure of diborane here, so we can draw the structure of diborane as it is B2H6, right? So we have a banana bond here, a banana bond here, right? One hydrogen atom here, one hydrogen atom here. So this is not a normal bond. These are not two normal bonds. We have a banana bond here. Okay. So it asks which is correct statement for diborane. Statement 1 says boron is sp3 hybridized. So that is a correct statement, as we can see that boron is forming 4 different bonds. So boron will be sp3 hybridized. Taking a look at option 2 says there are 2 terminal BH bonds for each boron atom. As we can see here, there is 2 terminal atoms here, right? 2 terminal BH bonds here and 2 terminal BH bonds here. So statement 2 will also be correct. And if we take a look at statement 3, it says 3 carbon 2 electron bonds. Okay, so this means that there are 3 atoms, 2 electron bonds are present above and below the molecular plane. So the 3 center 2 electron bonds is known as the banana bond, right? The banana bond is 3 center 2 electron bond. So it is present, one is present above the molecular plane and other is present below the molecular plane. So this statement is also correct. So the correct answer will be option 4, all of these. Moving on to the next question, we have which of the following statements about benzene and its reactions are correct? Statement 1 says halogen in aryl halide is OP directing and activating in nature. So if we talk about an aryl halide, in an aryl halide we have a benzene ring, and on that we have a halogen attached. So one might get distracted or from this lone pair which is present on the halogen atom. But what we have to keep in mind, while the halogen atom will show a plus M effect, it will also show a minus I effect due to its high electronegativity. So because of this high electronegativity, the minus I effect dominates the plus M effect. So overall, the halogen group is electron withdrawing in nature via an inductive effect. So it deactivates the ring. So the statement 1 will be incorrect because the halogen does not activate a aryl halide. Okay. If we take a look at statement 2, it says benzene forms triozonide, indicating the presence of 3 double bonds. So benzene has 3 double bonds, but it does not form does not form triozonide. So statement 2 will be incorrect. If we take a look at statement 3, so benzene reacts with chlorine in the presence of light to form hexachlorobenzene. So this statement is correct because benzene can undergo substitution reactions with chlorine or bromine in the presence of light, right? So hexachlorobenzene or hexabromobenzene is formed. So we can conclude that only one statement is correct, right? And this will be our option 3. Moving on to the next question. The question says the distillation technique most suited for separating glycerol from pent 1-ine in the soap industry is, right? So we know that glycerol, right? Glycerol has a low boiling point. Also, glycerol decomposes before its boiling point, right? When we are boiling glycerol, it decomposes while it's being boiled. So at 290 degrees Celsius, when glycerol boils, it also decomposes. So we have to make sure that glycerol does not decompose while we are boiling it. So how do we do that? So if we reduce the pressure, so when we reduce pressure, we know that the boiling point decreases. So if we reduce the pressure, so the boiling will take place at a lower temperature and the decomposition temperature of glycerol will not be reached. So if we carry out distillation under reduced pressure, so glycerol and pent 1-ine can be separated. So the correct answer will be option 2. Moving on to the next question. The question says, what is the pH of a 0.01 molar aqueous solution of acetic acid given that its pKa is 4.74. So we have been given the pKa of acetic acid as 4.74 and we are also been given its concentration as 0.01 molar, right? Which we can write as 10 raised to the power minus 2 molar as well. Okay, so we can solve this question in the long method while dissociating CH3OH, COH and using its dissociation constants to find out the value of the pH. But we also need to, from the exam point of view, we need to understand, we need to learn this formula for finding out the pH directly for a weak acid. So the formula is pH is equal to half pKa minus half of log C. So we directly substitute the values of pKa and concentration. So when we substitute, we get the value of pH as 3.37. So the correct answer will be option 3. Moving on to the next question. The question says the enolic form of acetone contains, and we have to talk about the enolic form of acetone and the type of bonds and the number of bonds present in that. So if I first draw acetone, so this is the ketonic form of acetone. And what happens in tautomerization, when the enol form is formed, a hydrogen from the alpha carbon forms a bond with the oxygen and a double bond is formed between the two carbon atoms. So this will be the enol form of acetone. So if we take a look here, we have one pi bond here and two lone pairs on oxygen atom. And if we count the number of sigma bonds, so here we have 3 CH sigma bonds. Here we have one CC sigma bond. Here we have one CC sigma bond. Here we have two CH sigma bonds. Here we have one CO sigma bond and one OH sigma bond. So in total we have 9 sigma bonds, one pi bond and two lone pairs in the enolic form of acetone. So the correct answer will be option 1, which is 9 sigma bonds, one pi bond and two lone pairs. Moving on to the next question. The question says, what is the maximum number of electrons that can be present in the fourth shell of an atom? Okay, so when we talk about a shell, right, so the principal quantum number n denotes the number of the shell. So here we have n is equal to 4. So the number of orbitals in a shell is given by n square. The number of orbitals is given as n square. So the total number of electrons will the total number of orbitals in the fourth shell will be 16. And we know that each orbital can accommodate 2 electrons. So the total number of electrons will be 2n square. So we can write it as 2 into square of 4, which is equal to 2 into 16, which gives us 32 as the total number of electrons that can be accommodated in the fourth shell of an atom. So the correct answer will be option 4, which is 32. Moving on to the next question. The question says, which of these elements exhibit the highest covalent character? So the covalent character depends on the polarizing power and the polarization of the ions, right? So the weaker that the charge is, right, or the greater that the cation is, the lesser will be the polarization and therefore the sorry, therefore the bond will be more covalent. So if we take a look here, here in NaCl we have Na plus, in MgCl2 we have Mg2 plus, in AlCl3 we have Al3 plus, and in SiCl4 we have Si4 plus. So Si4 plus will be the largest cation of all. So it will have the least polarization and that is why the highest covalent character will be caused in SiCl4. So SiCl4 is the molecule with the highest covalent character. So correct answer will be option 4. Moving on to the next question. The question says, consider the following reaction at equilibrium. The reaction occurring is 2NO plus O2 gives 2NO2. If helium is introduced at constant pressure, then what will happen? So first of all, we need to understand the concept of adding an inert gas at constant pressure. So when we are adding inert gas at a constant pressure, so the number of moles of gases is increasing in the system. But because the pressure is constant, so what will happen is that the volume will increase. So what will that cause? That will cause that the equilibrium mixture to shift the equilibrium in a direction where number of moles of gases formed are more, right? Because the volume will increase, so the equilibrium will shift to the direction where we have more number of moles. So if we take a look here, in the product side we have 2 moles of gases, and in the reactant side we have 3 moles of gases. So the equilibrium will shift backwards, which means that NO2 will be dissociated, which means that dissociation of NO2 will increase because the reaction will start moving backwards. So the correct answer is option 3. Moving on to the next question. The question says, in a compound containing a metal ion Mx plus, where Z is equal to 24, with a spin-only magnetic momentum of root 15 Bohr magnetons, how many unpaired electrons are present in the compound? So for that, we need to know the formula for the calculating the spin-only magnetic momentum. So the spin-only magnetic momentum is given by this formula, which is under root n multiplied by n plus 2, and that gives us the formula for, and that gives us the value for the spin only magnetic momentum. So if we find out the value of n here, we'll get the value of the unpaired electrons, because n is the number of unpaired electrons. So when we square both sides, we get n square plus 2n is equal to 15. So we get a quadratic equation, n square plus 2n minus 15. So when we solve the quadratic equation, we get two values for n, which is minus 5 and 3. So since the number of unpaired electrons cannot be minus 5, the number of electrons cannot be negative, so we have to take the number of unpaired electrons will be equal to 3. So the correct answer will be option 4 for this question. Moving on to the next question. The question says, for the reaction 2Cl minus is converted to Cl2 gas, the correct option is, okay, so what is happening is we have 2Cl, it is being converted into Cl2, right? So what is happening here is that two Cl atoms we have, and they are being converted into a chlorine molecule. So what will happen is a chlorine-chlorine bond will be formed first of all, right? So when the bond is formed, so when a bond is formed, the heat is released always, which means that the delta H will be negative for this reaction, right? And what is happening here, we have two different atoms, and it is being converted into one entity. So what is happening here, we have two different atoms which is being converted into one entity. So when that happens, the entropy is decreasing because the randomness is decreasing as two atoms are combining to form one. So the change in entropy will also be negative in this case. So both enthalpy and entropy are negative, so the correct answer is option 3. Moving on to the next question, we have identify X and Y respectively. So in the question we have 4 isopropyl toluene, and it is being reacted with bromine in the presence of light to give X, and bromine in the presence of anhydrous FeBr3 in the presence of Y. So when bromine reacts with the aryl with an aryl group in the presence of FeBr3, so what happens is FeBr4 is formed as well as Br plus is formed. So Br plus will attack the benzene ring directly because benzene ring is highly electron rich, right? So the Br plus acts as an electrophile, and it will attack the ortho position to the methyl group. Okay, so the compound that will be formed will be 2-bromo 4-isopropyl toluene. So the major product Y will be 2-bromo 4-isopropyl toluene, which can be seen in option 1 and option 3. So we can cancel out option 2 and option 4 because it does not attack at this position because of the large groups here. Because of this isopropyl toluene group attached here, so the bromine will not attack on the meta positions. Okay. So now if we take a look at what will happen in the case of when bromine is reacted with in the presence of light. So what happens is when we are talking in presence of light, so the Br2 is broken into two Br radicals. right? And we know that bromine radical is highly selective for a tertiary carbocation, for a tertiary carbon atom, right? So here we have a tertiary carbon atom. If I draw the structure of 4 isopropyl toluene once again, right? So here we have a 1 degree carbon atom, here 2 degree, here also 2 degree. This carbon is 1 degree. Only this carbon is a tertiary carbon atom, and the tertiary carbon atom is highly susceptible to a attack by bromine radical. That is why the bromine radical will attack here, and we can see this in the option 3. So option 3 will be our correct answer. This is X and this is Y. Moving on to the next question. The question asks, which of the following carbocations is expected to be most stable? Right. So we have NO2 group attached and we have a carbocation here. So we know that NO2 is a strong electron withdrawing group, right? It withdraws electrons from the benzene ring by a minus M effect, right? And the minus M effect is strongest at the ortho and para positions, right? So, so not OP directing. So the ortho and para positions are the most electron deficient in the presence of a NO2 group, right? So when it applies a minus M effect, so the ortho and para positions will be the most affected by the minus M effect. So ortho and para positions will be deficient in electrons, right? So for stability of carbocation, the carbocation should not be present at either ortho position or para position to the nitro group. So option 3 will not at all be stable, right? Now considering we have these, right? So in these we can clearly see that if the carbocation is present directly besides the NO2 group, so NO2 will also apply a minus I effect, a very strong minus I effect. So that will destabilize these carbocations. So the only stable one will be option 2. Option 2 will be the most stable carbocation in the following question. The next question says, assertion, it's an assertion reasoning type question. So the assertion says the pH of rainwater is in the range of 5 to 5.5, and the reason says carbon dioxide present in the atmosphere reacts with the rainwater to form carbonic acid, leading to the presence of H plus ions in rainwater. So assertion is a correct statement because the pH of rainwater is in the range of 5 to 5.5. So assertion is a correct statement. Whereas if we talk about the reason, so the reason says carbon dioxide present in atmosphere reacts with rainwater to form carbonic acid. Up till here, the reasoning is perfectly correct. But after that, it says leading to the presence of H plus ions in rainwater. So we know that carbonic acid is a very weak acid. So it does not dissociate to release H plus ions. Therefore, the assertion is a correct answer, but the reasoning is incorrect. So option 3 will be correct, which is assertion is correct and reason is incorrect. Moving on to the next question. The question says, which of the following statement is incorrect? We have 3 different statements and we have to tell which of the following is incorrect. So statement 1 says, the bond angle in pH 4 plus is higher than that in pH 3. So in pH 3, if we take a look at pH 3, so what is happening in pH 3? We have a lone pair here, and whereas in pH 4, in place of the lone pair, we have a hydrogen atom, right? And the entire molecule carries a plus positive charge. So we know that the lone pair bond pair at repulsion is more than the bond pair repulsion. So here the repulsion will be higher, and that is why the bond angle will decrease. So the statement that bond angle in pH 4 is higher is true, is correct. Okay, so this statement cannot be incorrect. So this is not our answer. Statement 2 says tritium is the radioactive isotope of hydrogen. So in tritium we have, this is tritium, right? We have 1 proton and 2 neutrons. So tritium is radioactive, and that is why this statement is also correct. However, statement 3 says ozone is not an allotropic form of oxygen, while ozone is an allotropic form of oxygen. Okay, so allotropes, what is allotrope? Allotrope is the different form of the same element, and they should be present in the same physical state as well. So we know that oxygen is O2, right? And it is present in the gaseous state, and ozone is O3 and it is also present in the gaseous state, right? So only the bonding is different, but the physical state and the element is same. So O2 and O3 are allotropes of each other, which means that ozone is an allotropic form of oxygen, and statement 3 is incorrect. So the correct answer to this question will be option 3. Moving on to the next question. The question says, how many compounds out of the following have the same IUPAC name? So we have been given 8 different compounds, right? And we have to find out how many of them will have the same IUPAC name. So if we take a close look at these compounds, so in these, if we start naming the carbon chain, the parent carbon chain, so we'll see that each carbon chain has different length of the parent carbon chain, or the hydroxyl group is attached at a different location. Here the hydroxyl group is at the carbon 1. Here the hydroxyl group is at carbon 2. Here it is at 3 and here it is at 1, but the numbering is different, right? We have a branching here at the second carbon. In this we have a branching here at second carbon, but it is doubly branched. Here we have a branching at the third carbon atom. Here we have a branching at third carbon atom, but the OH is present in the second carbon atom, right? So in this way we can see that all of these compounds are different, and when the structure is different, when the compound is different, so it will obviously have different IUPAC name. So none of these compounds have the same IUPAC name. Correct answer will be option 4. Moving on to the next question. The question says, identify the correct statement for change of Gibbs energy for a system, del G of the system at constant temperature and pressure. Okay, so we have to find out the correct statement about the change in the Gibbs free energy of a system. Okay, so option 1 says, if delta G system is equal to 0, the system has attained equilibrium. And this statement is correct. At equilibrium, the change in free energy becomes 0. Okay. Other things about delta G is that when delta G is less than 0, the reaction is spontaneous, whereas when delta G is greater than 0, the reaction is not spontaneous. Okay. So let's take a look at the other options as well. If delta G system is 0, the system is still moving in a particular direction. No. When delta G becomes 0, the system attains equilibrium. Correct statement is option 1. Uh, Statement 3 says, if delta G system is less than 0, the process is not spontaneous, which is incorrect. And if delta G system is greater than 0, the process is spontaneous, which is also incorrect. Moving on to the next question. The question says, equimolar aqueous solutions of which compound will have the highest pH? And we have 4 different solutions, which is NaNO3, NH4Cl, CaCl2 and Na3PO4. So it is asking us which of the following compounds will have the highest pH. So we know that the salt of weak acid and strong base on hydrolysis will give a basic solution, right? When we have a weak acid and strong base which form a salt, the hydrolysis will give a basic solution. So in this case, if we take a look at NaNO3, we have NaOH, and it is formed by NaOH and HNO3, which are both strong acid and strong base. So we'll have a neutral solution, right? In NH4Cl, we have a strong acid and weak base. So we'll have an acidic solution. In CaCl2, we'll have a neutral solution. And in case of Na3PO4, we have NaOH and H3PO4, right? So we'll have a basic solution in this case. And for a basic solution, the pH will be greatest. So the correct answer is option 4. So now moving on to the last question of the part test 1, we have the correct order of atomic radii of group 13 elements is. Okay, so generally what happens is when we move down a group in the periodic table, the atomic radius increases. However, in this case, we have an exception. Okay, so do not mark option 2 as correct because of the order in the periodic table. There is an exception in group 13. What happens is that the radius of gallium is less than aluminium. And why does that happen is because when we reach the third period, the filling of the d orbital starts in the fourth period, right? So when the d electrons have started filling, so what happens is the d electrons do not shield the nucleus effectively. As a result, the electrons in gallium, the electrons in the valence shell of the gallium, they experience a greater force of attraction by the nucleus. Okay, that is why the atomic radius of gallium will be less, as the electrons which are present in the valence shell will be attracted closer to the nucleus. Okay, so the correct answer will be option 4, right? Boron, gallium, aluminium, indium, and thallium, right? So this is it for the analysis of part test 1 chemistry. Hope you all understood it. Thank you.